Okay, so this next video is going to deal with the average value of a function and also use the fundamental theorem of calculus here to help us determine some things that we need. The average value is a simple concept that sometimes people make too difficult, so we're going to try and go through this very simply. The first thing that we want to do is see what we've been given. So it looks like we've been given Juno's speed in miles per hour. T hours after entering the freeway is given by. So we've got this speed or velocity function, and we know that t is greater than or equal to 0 or less than or equal to 0.5. So let's see what we've got here. In part A, it says find an expression giving the distance Juno traveled as a function of t. So remember, v of t is the velocity or speed, which is the first derivative. So if we anti-differentiate that first derivative, we'll end up with our distance function. So the first thing that we want to do is simply anti-differentiate our function. And when we anti-differentiate that, we end up with a very simple situation. And you know at the end of that there is going to be a plus c, but in this situation I think we could all agree that that c is going to be 0 simply because we know that at a time of 0 the distance is going to be 0. So that's just a little thing that we go through there, and that's just actually anti-differentiating the velocity function to get the distance function. Then in part B it says how fast was Juno traveling at 0.2 hours? Well, his speed or velocity comes from our original function, so for that we just need to evaluate v of t. So if we're going to evaluate v of t, we'll actually go through and use Excel to do that in just a minute. And then in part C, how far did Juno travel between 0.2 hours after entering the freeway and 0.4 hours? So now this one is going to require fundamental theorem of calculus. And you can see that in my written out piece here, I've said use d of t, which was our antiderivative of the velocity function, and we want to evaluate it from 0.2 to 0.4. And then in our last situation, what was Juno's average speed during the time interval from 0.2 hours to 0.4 hours? And with that, I've just given you another thing there, that we've got the average is going to be equal to the distance divided by the time. So let me move this off to the side and let's look at what we have. So first of all, if you look, this is going to answer where I'm have my highlight now at 0.2. This is going to be where I'm evaluating Juno's speed. So at 0.2, notice here I've simply typed in my velocity function. That was the function that I was given at the beginning. And it looks like that at 0.2 hours after entering the speedway, Juno is going 71.74 miles per hour. If you come down here, this is where we're going to see fundamental theorem of calculus. So we've got 0.4, 0.2, our upper limit and our lower limit. We're going to anti-differentiate. So this is where you see my antiderivative. And I've double-clicked that down. So we basically have, these are distances, right? So I want you to think about what they are. So those are going to be the distances. So this is going to be the total distance traveled, so that's going to be the miles traveled from 0.2 hours to 0.4 hours. Then what I want you to think about is, well, how could we find that average speed? Well, remember the average speed is going to be the distance divided by the time. So when you look here, the way that I've typed this in, I have my 14.69 miles divided by my time, 0.4 hours minus 0.2 hours. And when I enter that, that tells me that the average miles per hour during that time frame is 73.45 miles per hour. Don't make average harder than it needs to be. You are always going to first use fundamental theorem of calculus, and then the second thing that you're going to do is divide by the difference between your upper limit and your lower limit.